Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear students, how are you? I hope you are fine and safe. Our today's topic, basic concept of combination, chapter number 5B. Now I want to discuss about combination. Our today's topic, what is combination? Find the value of NCR, relation between permutation and combination, complementary combination, and last one is conditional combination. Now, first one, what is combination? Each of the collected numbers which could be formed out of some n numbers of different things taking r at a time without regarding the orders of things is called combination. Here n and r are two positive integer number and one condition is applicable here: n greater than equal r. N greater than equal r. The combination is denoted by here NCR or NCR or C of n comma r. Now for example, suppose there are three characters A, B, C. The combination of three characters taken two characters at a time are here AB or BA, BC or CB, AC or CA. For combination, order is not necessary. That's why here AB and BA are same, BC and CB are same, and AC or CA are same. So number of combination will be here total characters here 3, so we can write 3, and combination 3 characters taken 2 characters from here, so we can write here 2. Now after calculation we can write here 3, so our answer is 3. Now we can write the formula of combination here: N C R equals to factorial N factorial R factorial N minus R. So now we can find out some important formula from this formula. Now here, if r equals to 0, if we put r equals to 0, then NC0 will be here factorial N factorial 0 N minus factorial 0 N minus 0. So here our answer will be n factorial n by factorial n. So our answer will be 1. Our answer will be 1. Again, if r equals to 1, then NC1 equals to, we can write factorial n, factorial 1, n minus 1, here factorial. So after calculation, here we can write n minus 1 here, n into factorial n minus 1, and here factorial n minus 1. Here factorial n minus 1, factorial n minus 1 will be cancelled, so our answer will be n. Our answer will be n. Again, if we put r equals to n, then our answer here NCN equals to factorial n, factorial n, factorial n minus n. So our answer will be 1. Here factorial n by factorial n and factorial 0, so our answer will be 1. Again, NC0 equals to 1, NC1 equals to n, and NCN equals to 1, and NCN minus 1 will be n. Suppose here, if we put n equals to 7 or any kind of number and combination 0, 7C0 or 8C0, it will be 1. Same as 10C0 equals to 1. Now for this condition here, if we put here 7C1, our answer will be here NC1, answer will be n. So here 7C1, answer will be 7. Again, if n equals to r, here NCN equals to 1. So here we can write 5C5. Suppose 5C5 equals to 1. And last one here, if NC, and here if NCN minus 1 equals to n, our answer will be n. If n minus 1 is less than 1 from n, so example is here 7C6, here their difference equals to 1 and 6 is less than 1 from 7, so our answer will be 7. So our answer will be 7. If 9C8, our answer will be 9. Here 5C4, our answer will be 5. Here 5 and 4, their difference 1, 7 and 6, their difference 1, 9 and 8, their difference 1. So our answer here 7, C6 equals to 7, 5C4 equals to 5, 9C8 equals to 9. This type of formula, which is very important for our MCQ test and mathematical problem. Now, relation between permutation and combination. All we know that the formula of permutation here, NPR equals to factorial n by factorial n minus r, and the formula of combination NCR equals to factorial n by factorial r n minus r, here factorial n minus r. Now here we can write NCR equals to factorial n by factorial r into factorial n minus r. So now we can separate by this way, 1 by factorial r into factorial n by factorial n minus r. Here NPR equals to factorial n by factorial n minus r. So now here we can put this value of NPR. So we can write 1 by factorial r into here NPR, which is the value of factorial n by factorial n minus r, NCR. Now we can apply cross multiplication method. So here we can write factorial r into NCR equals to NPR, which is the required solution of relation between permutation and combination. Now, complementary combination. To prove that the number of combination of n different things taken r at a time is equal to the number of combinations of n different things taken n minus r at a time, that is NCR equals to NC n minus r. Now we can prove. Here all we know that the formula of combination NCR equals to factorial n by factorial r factorial n minus r, and here taken n minus r at a time. So we can write r equals to n minus r, NC n minus r. So it will be factorial n by factorial n minus r and factorial n minus n plus r. So here we can write factorial n factorial r factorial n minus r, but here NCR equals to factorial n by factorial r into factorial n minus r. So we can write here NCR, that is NC n minus r equals to NCR. Combination of such type is called complementary combination. Now, for some mathematical example, we can write here. Suppose example, here we can write 10C7 equals to 10C. Here 10 and 7, the difference of 10 and 7 is 3. Another example is here 15C8 equals to here 15C7. Combination of such type is called complementary combination. Now one thing, if NCX equals to NCY, then X is always equals to Y. Condition number 1, X is always equals to Y, and condition number 2, here X plus Y equals to N. If NCX equals to NCY, then first condition, X is always equals to Y, and another one will be X plus Y equals to N. Now one formula, here we can write NCR plus NCR minus 1 equals to here N plus 1 CR. Here R and R minus 1 are two consecutive number, so here if n equals to n, then it will be n plus 1 CR. Some mathematical example is here. Suppose 7C5 plus 7C6. Here 7C5 and 7C6, here 5 and 6 are two consecutive number, so it will be here 7 plus 1 C6, here 5 and 6, here 6 is greater than 5, so here answer will be 6 and it will be 8C6. Another example is here 8C4 plus 8C3. Here answer will be 8 plus 1 9C. Here 3 and 4 are two consecutive number and 4 is greater than 3. So here we put 4. Now conditional combinations. To find the number of combinations of n different things taken any number at a time, it will be 2 to the power n minus 1. Here prove that. Suppose the number of combinations of n different things taking 1, 2, 3, and so on, n things at a time. So we can write here nc1 plus nc2 plus nc3 plus and so on plus ncn. But all I know that from binomial nc0 plus nc1 plus nc2 plus nc3 plus dot dot and so on plus ncn equals to 2 to the power n. Suppose here from binomial nc0 plus nc1 plus nc2 plus and so on ncn equals to 2 to the power n. Now here we can add nc0 plus nc1 plus nc2 plus nc3 plus and so on ncn, but here extra part is nc0. For balance we can write here minus nc0 minus nc0. From binomial this part will be 2 to the power n. From binomial we can write here 2 to the power n. Here nc0 equals to 1, so 2 to the power n minus 1. And now suppose mathematical example. A man has 5 friends. Could he invite one or more friends? So the man could invite 1 or 2 or 3 or 4 or 5 persons at a time out of his 5 friends. So we can apply this formula 2 to the power n minus 1. So answer will be 2 to the power 5 minus 1. Here 2 to the power 5 equals to 32 minus 1. So answer will be 31. Now another one. The number of combinations of the things of which A are alike of first kind, B are alike of second kind, and C are alike of third kind taken any number at a time is. Suppose A things may be disposed of in A plus 1 ways, for we may take 0 or 1 or 2 or 3 or a number things from first kind. Similarly, B and C things may be disposed respectively of in B plus 1 and C plus 1 ways. Taken all kind of things in together may be disposed of in here A plus 1, B plus 1 into C plus 1 ways. But this includes the case in which all the things are left is not acceptable. That's why the number of combination equals to A plus 1, B plus 1, C plus 1 minus 1. That's why minus 1. Again, if and different things added here, then the number of combinations will be, if different things added here, then the number of combinations will be a plus 1, b plus 1, c plus 1 into 2 to the power n minus 1. This part for when n is different things added here, then the number of combinations will be a plus 1 into b plus 1 into c plus 1 into 2 to the power n minus 1. The number of combinations taken at least one of each kind in which a things are alike of one kind, b things are alike of another kind, and c things are alike of another third kind. Our formula will be 2 to the power a minus 1 into 2 to the power b minus 1 and 2 to the power c minus 1. For example, a committee could be formed, each consisting of at least one of 4 students of class 8. 4 students taken 1, and at least one of 5 students of class 9, 5 students taken 1, and at least one of 3 students of class 10, 3 students taken 1. So we can write here, we can apply this formula, for this type of math. So we can write here, from class 8 total student 4 taken 1. So we can write here 2 to the power 4 minus 1 into here class 9, from class 9 total 4 students taken 1. So we can write here 2 to the power 5 minus 1 into from class 10 total 3 students we can take 1. So we can write here 2 to the power 3 minus 1. After calculation, our answer will be 3255 ways. 32. Now, to find the number of ways in which m plus n number of objects could be divided into 2 different teams consisting m and n things respectively. Here, out of m plus n things could be selected in m plus n c m ways, and for each such things n things remain left, from which n things could be selected in NCN equals to 1 ways. So required number of combinations, number of combination equals to here m plus n c m into 1 equals to, here we can write factorial m plus n, here factorial m, here m plus n minus m. So our answer will be here factorial m plus n, factorial m, factorial n. So factorial m plus n divided by factorial m into factorial n is one kind of formula. Now our last conditional combination is here. To find the number of combinations of n different things taken are at a time in which p particular things always occur and where r greater than equal to p. R greater than equal to p. So required number of combination will be n minus p c r minus p. Again, to find the number of combinations of n different things taken are at a time in which p particular things never occur. So required number of combinations will be here n minus p c r. For p, for this part p particular things always occur, that's why n minus p r minus p. And here for this portion here p particular things never occur, that's why n minus p c r. Thank you to all.